How's everyone doing? Good. It's been a long day, but a good day. And so I get to take you out into the reception after this, and that's a good thing too, right? Yeah, there's a reception at 6 in the vendor hall, I think. So here's the life of someone who speaks a lot. I thought all of these were 45-minute sessions. So it turns out this is 20 minutes, and I'm still going to figure out how to accomplish this, and it's going to be awesome. So this is going to be a whirlwind tour of partitioning in Postgres as a start. Please come talk to me afterwards if you want. I love partitioning, I love security, love just talking about lots of stuff about Postgres. So please don't hesitate to come find me. This is who I am. My name is Ryan Booz. I work for Redgate, is the major, the sponsor and the host of Past Data Summit. And we were fortunate enough to be able to work with the people Postgres data, JD and folks to help make this possible as a first go. We realized, hey, we have some spare space and we would love to start to help other database communities. And so we're glad you're here. And please connect with me any of these places. It's pretty easy to find me. So this is a quick agenda. It's so quick I'm not even going to read it like I normally would. You see it, let's go. So the what and the why. So what are partitions? Partitions are just regular tables in Postgres, right? So we have a table, they have schemas, they can have table spaces. They can have some unique things apart from their parent, but generally they are just regular tables that are in this unique way attached through a parent. So when we say a partitioned table, that is really the parent that we're saying this thing is going to be split up, and the partitions are the children. And so they can have self-contained indexes. They don't have to fully match the parent, depends on your use case. And then they themselves can also be partitioned tables. They can be a parent of further partitioning. We'd call that subpartitioning. What I'm going to talk about in these few minutes is declarative partitioning. So that was introduced in Postgres 10. Generally, we say don't use it. Postgres 11, there were some fixes that really made it very usable and a great option for doing this. Before declarative, inheritance was really the only way to do it. It is still available. You can still do inheritance-based partitioning if you want. Probably not what you need most of the time, because this works so well for most use cases. So you have to identify the column or columns, depending on the partitioning type you're using. That is going to be how it is partitioned out, right? So things like range, we support range, list, and hash. In time series databases, that's typically a date or timestamp, right? So you're getting data at regular intervals with a timestamp, and you're going to group maybe a month of data together. So that's a really easy use case. Hash, I'm going to go through them on the next couple slides, so I don't know why I'm doing that. Partitions. This is the one thing with declarative partitioning. Currently in Postgres, with this feature in core, the partitions are not created for you. So if you have a range partition based on time, if new data keeps coming in, and it's supposed to be for the month, and the month flips over and you start getting data, if the partition's not there, you'll get an error. And so you do have to have some mechanism for making sure those partitions exist before the data comes in. There is a default partition, literally called default, which is a catch-all, but it does present some challenging maintenance headaches if you happen to not have the partition when the data comes in and you have to go down the line there. So this is an example of just the table I'm going to use throughout this. This is the copy. This is what I'm basing my partition table on. And so I'll quickly show you. I'm going to create it as a payment to table so that we can show you partitioning. So for this example, I'm going to partition based on date. It's time series data from my perspective. There's lots of ways you could go about this. I actually have a longer version of this that gets into subpartitioning, some other options, but we're just going to do this for the time that we have. So this is time series data. Now, Bruce had a talk earlier talking about the planner, and so we start with if there's nothing. I just have a table. There's no indexes, no constraints, nothing. If I were to run this query, Postgres has no choice but to scan the entire table. And so obviously, the bigger this table gets, the longer that's going to take, and everyone's going to be unhappy. However, even if you go ahead and add an index, which is a much better approach, right? If I'm going to query on that, I'm going to get an index. The index will at least point to the specific pages where the data I'm looking for exists, right? So they might not all be together, but at least I'm not going to scan every single page most of the time for a query like this as the table gets larger. However, if I'm not always querying the older data, that index is getting bigger, and obviously if things get, depending on what you're indexing as, things might get kind of fragmented and so forth. If I can contain those indexes to each individual partition in that data, then when I query it, I don't even have to look at the other stuff. I know that all the pages for the data for September exist within this partition, right? It's never going to exist in any of those other partitions, so I can just ignore them. And so that helps both in query planning and honestly just in data management, right? So not only that you're reducing the space of your data, but eventually if I have to get rid of the data, we archive data over time, it's much easier to do it on a partition than to copy all the data or drop all the data out of the large table, which presents all kinds of other problems. I'm going to skip over this slide because it's not exactly what I want to show, and we'll move on. And then, like I said, so data retention archiving, that's one of the other really awesome values with partitioning. Because now, before you would partition, if I need to drop a month of data 2 or 3 years from now, I'm literally doing a delete. We know in Postgres that doesn't actually delete the data. It simply marks it for deletion. And if things aren't working well, you can get table bloat, all kinds of other bad things. And if it's not partitioned, the pages you're deleting from could be all over the system, right? They're not at least somehow contained in a specific location. And so now you can simply, with partitions, you can detach it. So that'd be a great way to archive. Like, hey, don't consider this anymore. It's not part of the table, but I'm not deleting the data yet. That, and you just one command, and it's now no longer considered for your queries. Or it's just a table. So if you literally do need to just delete the data, drop the table. It's a quick operation. There's no table bloat, and you can just keep moving on. So the types of partitioning. I added this recently because I realized as I'm talking, it wasn't as clear. So partition table is where you specify the column or columns, how you're going to partition the table. The partitions themselves, when you create them, is when you specify the values that those partitions will be holding, right? So you don't, at the parent, say, by the way, I want you to do range partitioning, and it's going to be all of these ranges for these specific constraints. So the partition table, you're just saying, hey, partition based on this column, and then as I add the partitions themselves, I'm identifying the values that it should store. So the 3 types of partitioning. We have range. I would say it's one of the most common I see nowadays, mostly because we have so much time series data. And so everyone ends up with big log tables or big transaction tables, and eventually they realize we want to manage this in a different way, and partitioning helps with a lot of that. And so it's the one thing to understand, it's inclusive of the lower value always. So ranges in Postgres, if you use a range type, you can specify if it's inclusive of this value or not. If it's inclusive, you get to specify all 4 combinations. With range partitioning, it's always inclusive of the lower value you specify and always exclusive of the upper value you specify. So January 1st to February 1st is actually all of January up to 59, 20, blah, 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 blah. And then the next one is beginning of 000 of February 1. Or it might be integer integer range of some sort. So it's actually 1 to 9 in the first partition, 10 to 19 in the second, and so forth. And as I said, this is essentially how you do range partition, right? So we're specifying the table, and you have to do this at creation time. You can't later partition a table. And so if you want to do that, you have to do some kind of expand and contract. You have to go and create a new table that is partitioned and copy the data in some form or fashion. So we say range, range partition by payment date, but we're not saying what the ranges are. That happens when we create the partitions themselves, right? So the partition itself is saying, I am a partition of payment 2, and these are the values that I store for payment 2. A constraint gets added, and now payment 2 knows when data comes in for that constraint, it goes to this partition. List partitioning is really helpful for things like, for known values. Maybe it's areas of the country. Maybe it's divisions within a corporation, something of that nature. Maybe it's types of toys and the categories they have. And again, it's a new partition type, right? It's just partition by list this time. The column that holds the values that we're going to list them partition by. And then, so an example might be if I'm doing it by state, the Northeast partition, US, if you're not from the US, I'm sorry, but the Northeast partition might include these states. Now, one of the things you just have to realize is you have to know the values. If an unexpected value comes in for state, the US grows, it has nowhere to go. You're going to get an error because no partition has been identified to store that value. So you do have to make sure you have all the values you expect. Question?
It doesn't get an error if it's the default, right?
If you've created the default. The default's not created by default. Wow, that was weird. And there's pros and cons. In the short time, I think I'll still be able to get to it. And then finally, hash partitioning. The great thing about Postgres is any data type can be hashed. And you can hash multiple data types together. So with hash, it's a really good way when either you aren't exactly sure how to spread data out across partitions, but you just know you want it to be spread out a little bit in some way, so you can manage it maybe across different table spaces or whatever that might be. Because eventually, it's going to kind of naturally become an evenly distributed data, because you're always getting some kind of modulus. One of the ways I have found to do this can be, well, I'll show you in the next couple slides. So an example might be like this. I have a rental ID, and I want to so every rental ID is new, but I just want this table to be spread across multiple partitions. So I don't want to set up the range 1 to 100 and 100 and 200. Like, that's too much work. And so I say, hash this thing. It happens to be an integer. And then when I create a bucket, I determine how many buckets, and you have to determine at creation time, right? So how many buckets, in this case, 8 different partitions. When it hashes that value, it does the division, whatever the remainder of the hash is, 0, 1, 2, 3, 4, 5, 6, or 7, it will then go into that partition. The cool thing about hash partitioning is you can actually specify multiple columns. So you can actually, don't get crazy with it, but you could, it's an interesting and useful way to evenly distribute data over time without you having to think as much about it. Now, it doesn't help as much with things like data archiving. It doesn't help as much with things like finding the specific value in, it's somewhere in that big table partition, but that partition might grow over time. I have generally found that hash partitioning is really good as a first step when you ultimately want to subpartition. So I really want time series data, but I do still need to go find that specific rental ID sometimes. And if I've only partitioned on time and I don't filter on time, then it has to go scan every single partition. But if I first divide this up into buckets, I'm kind of putting it at least in a smaller space to scan than all of the data. So that could be one way. Creating, I've shown you a little bit. The only other thing to note is this. And I'm doing this intentionally because there are a lot of ways you could do this, but just to point out, one of the features of Postgres is that, wow, someone from England's calling me. I wonder if it's actually someone from my company. Okay. The primary key, so if you have a unique constraint on a partition table, the partitioning key must be part of that or a unique constraint. It must be unique in and of itself. The reason's this. There is no global index. And so we can't guarantee uniqueness across partitions unless it's a unique constraint that's applied at the partition to start with, right? So we know that some combination of, in this case, so there's a couple ways. With time series data, technically this is unique. Do you really want to do payment ID and date? I mean, it is what it is. You're never going to have a payment ID with the same date time, right? You can only have one, so it's still a unique constraint. And that is one path forward of doing something like this with date time, if you have a unique constraint on your payment. And then I create these ranges, so I'm just creating more partitions of range values. The name can be whatever you want, and remember I said earlier that partitions have their own schema. You could create a schema for your partitions that might kind of hide it from folks, right? But it doesn't matter, you can still write data to it. The partition table knows where they're at, and it can go right to it. And then the last thing I would say, with the short period of time we have, is that generally, when you're using declarative partitioning, all of your DDL, number one, has to happen, the true DDL has to happen through the partition table itself. So the schema of all the children must match the parent. And in fact, thankfully, Postgres will prevent you from modifying any child partition, adding columns, taking columns away, changing data types, whatever. It would simply say you can't do that. You have to do it through the parent, and then the parent will go ahead and matriculate that down through all of the tables. Now, there are some things you can do with a partition. You can, so if I want to add a column, I would do that at the parent. So I say alter payment to, and it will get applied downward. Now, if I apply things like indexes, this will then automatically go create the index on all the children, which is really helpful. However, this is one of the things you can do independently on the table, right? It's a separate, unique object. The parent table has no idea that you've added an index. So sometimes it might be really helpful. You have a hot partition in some way. You know, maybe a lot of data came in 1 month with something else, and you recognize, oh shoot, this query's not working well in this partition. I'm going to add an index for right now. So you can actually do that at the child table. But when you do an index at the parent, it is not a global index. So, as I said earlier, if I had, I had a payment date and I think it was payment ID, right? If I some point need to go find that one payment ID in this scenario, I'm going to have to scan every single table because I partitioned on date, but there's a unique constraint on date in the ID. But the partition only knows about the date range. And so if you need to do this, again, there's other approaches. Maybe you start with a hash, and then you go to subpartitioning on date, something like that. And then data retention, I've already said this, you can just drop the table, you can detach it, and later, if you don't delete it, you can simply reattach it as long as the constraint still matches. And so this is a way that you can attach partitions of older data. You simply create a table, insert the data, have to make sure the schema matches, insert the data, make sure the constraints, you do check constraint to make sure there's no data in that table outside of whatever the ranges you're going to provide, and then you simply attach it with that range. And now you can add partitions later on if you want to. All right, and last but not least, I think we'll have to end here. And I can point you to, I think, a recording I have of this if you want to get to the, see the creation of partitions and so forth. The catch-all, it can be helpful. Most people would say just don't. Don't create it because you would rather get the error and fix it. But obviously, we live in the real world. And sometimes, especially with range partitioning, even if you have automation, somebody is going to say, oh, I found all this old data from 10 years ago. Let's load it. And you didn't have the part. You were creating partitions in the future, but you didn't have them set up, and then you get errors and everyone's unhappy. The big problem is, great, it prevents data loss. However, you don't want it to stay there because the query plan is that's just going to grow potentially, and you're not able to partition or prune that out of the query. And so this is the headache right now. If I want to get data out of default, I first have to create a table that's going to hold the new data. I have to essentially get the data out into that table. I then have to delete the data from the default partition because when I go to attach this new partition with the date range, the very first thing it always will do is scan the default partition to make sure there's no data there that would otherwise be in this new partition. So you have to go through that rigmarole. There are some tools that can help. I say it's often just a necessary evil help, sorry. So think about it, you can go through. A lot of people just name it default, right? Just so you know exactly what it is and you know what the partition is. There are ways to automate it. We can talk to you about any of these. Come find me if you need to. I'm not going to do the demo, but let me talk briefly about some tips and tricks. So number one, merging or splitting. This does not exist yet. It almost made it into Postgres 17. There were a couple things that were found at the end of August, and they decided to pull it out. So I do expect there will be some way through SQL to enact some ways of, hey, over time, I had maybe weekly partitions because I get lots of data. But eventually, I'm going to archive it, so I want to merge weeklies into a monthly partition. If I did that now, I would have to create the partition. I'd have to copy all the data. I'd have to delete all the other partitions, right? So I think this will come. You can accomplish it manually, but it is a headache. Partition size. Hey, shared buffers, I'm not going to go into it, but I'm sure you have heard this over and over again. 25% to start with, maybe up to 40, depending on the size of your server. Excuse me. The general rule of thumb is you want your hot partitions, the ones you're using most often, the ones that the data is going into right now. This is probably most important for things like time series data. You want them to be all fit in shared buffers because it can work really fast. If it has to keep going and pulling stuff because there's not enough space, so you have to take into account everything. All your other tables, all your other databases, your query stuff, and just adjust accordingly. Use buffer cache query just to see how your shared buffers is doing. Now, part of that then is size and number. You know, we used to say more than a couple hundred. Then we said, hey, you know, more than 1,000 might be problematic when query planning. Now, you can do 10,000, you can do 50,000. Yes, the more partitions you add, the catalog table has to keep track of all of them. There's a lock. If you have an index on every one of those, when you query a table, it's got to take a certain amount of locks for the indexes and quickly the lightweight locks and so forth. Be reasonable, right? Like, it doesn't help to have 50,000 partitions for a year of data. Like, it's just no good. Be reasonable. Think about what your need is, right? Especially with time series data. What? Do you need to drop every year you need to drop a year of data or the month of data? Okay, then maybe do it bi-monthly or do it bi-weekly, whatever that might look like. And eventually, if you really get up to 10,000, 15,000, 20,000 partitions, you will see an impact on query planning, and so it's just worth thinking about a little bit more. I just always say this, don't target it based on row count. Like, that's never going to work. Just don't do that. Think about size and think about what you need it for, particularly when it comes to data retention, something like that. And then I think 2 more here. Always filter by the partition key. That's the reason you're partitioning. Because if I don't filter by date, in this specific instance, it's going to scan every partition, and I've kind of lost the value when it comes to query planning and so forth. This is a hint just for Postgres 15 and below. Postgres 15 and below, if you do date math in your filter with a now, with intervals, it doesn't materialize at query planning time. So it will actually, in this case, 15 and below, it will plan to scan all the partitions because it doesn't actually know the date time at that moment. When it goes to execute, it has materialized that data. And basically what you'll see is, I think it says, I forget what it says. It basically says no query, it doesn't touch the table. So it does skip it later, but it does impact planning time. So if you can materialize it and put that in your query before you execute it, you'll have better performance. 16 and above, it actually does that as part of the planning now. And then, last thing is just you can use table spaces. Another really helpful way is as data gets older, you could move partitions to a table space that's maybe on cheaper storage, right? So you don't have to access it often, but it's there in case you do, but it's just not costing you nearly as much money. So it's a great way to think about that. That was a whirlwind tour. Woo! And we made it. Please come find me and talk if you need. Get ready to go downstairs and have some drinks and some food and see the vendors. And I think that is it. Cheers. I'm glad you guys are here.